Hi guys, today we're going to be looking at a question on reaction rates. The reaction between pure aluminium and excess hydrochloric acid is used to investigate the factors that affect the rate of reaction. The balanced equation for the reaction is, and this being the balanced equation. Question 5.1.1. Define the term reaction rate. So reaction rate is the change in concentration of products or reactants per unit time. Experiment 1. In this experiment, 1 mole per decimeter cubed hydrochloric solution, acid solution, reacts with 0.5 grams of aluminium strip from an aluminium roll at room temperature. The graph of volume of H2 versus time for this experiment, not drawn to scale, is shown below. Question 5.1.2. For the time interval t is equal to 0 to t is equal to 5 minutes, the average reaction rate for the formation of H2 is 0.033 decimeters cubed per minute. Calculate the mass of Al present in the container at t is equal to 5 minutes. Take the molar gas volume as 24.5 decimeters per mole. So since we have the rate and we have the change in time, we can calculate the change in volume of H2. So in this case, we have our rate being 0.033, change in volume over 5 being our time. We then get our volume to be 0.165 decimeters cubed. Now that we have our volume and we have a molar gas volume, we can calculate the moles of H2 produced. And if we plug all of this into the calculator, we should get 6.74 times 10 to the negative 3 moles. We then look at our formula and figure out the mole ratio between H2 and Al. So for every 2 moles of Al, we have 3 moles of H2. So we can say that the moles of Al is equal to 2 over 3 moles of H2. We then take 2 over 3 and we multiply it by the moles that we have just calculated. And when we plug all of that into the calculator, we should get 4.49 times 10 to the negative 3 moles. We then can calculate the mass of Al. As we know, mass is equal to moles times molar mass. And we have the moles being 4.49 times 10 to the negative 3. And we have a molar mass of 27. We then get our mass to be 0.12 grams. And that's how many grams reacted total in the whole reaction. We then take our initial mass that we have of being 0.5 and we minus the amount that reacted and we get 0.38 grams. And that is how much of Al is remaining in the container after 5 minutes. Assume that the concentration of HCl stays constant for the duration of the reaction. Question 5.1.3. Use the collision theory to explain the change in reaction rate from T0 to T5. So here we can say that the surface area or the size of the aluminium decreases, causing less particles to be exposed. This results in less effective collisions taking place per unit time, causing the reaction rate to decrease. Experiment 2. Experiment 1 is repeated using a 2 mole per decimeter cubed hydrochloric acid solution. Question 5.1.4. Redraw the above graph. No numerical values needed to be shown in your answer book and label the curve A. On the same set of axes, draw the curve that will be obtained for experiment 2. Label this curve B. So we already have this curve being A, though you will redraw it in your answer book and label it A. And B, since we have a higher concentration of hydrochloric acid, it will still start at 0 and it will still end at the same point. However, the reaction rate will be a little bit quicker. Therefore, this graph will be B. Experiment 3. Experiment 1 is repeated using 0.5 grams of pure powdered aluminium. Question 5.1.5. How will the volume of H2 produced in experiment 3 compare to that of experiment 1? Choose from greater than, less than, or equal to. The reaction rate will still be, the volume of H2 produced will still be equal to that of experiment 1, as it is still the same amount of Al used. However, since it is powered at AL, the reaction rate will just be slightly quicker, but the amount of H2 gas produced would still be the same. Therefore, it is equal to. Question 5.2. Curve X is a Maxwell-Boltzmann distribution curve for a reaction under set reaction conditions. A change was made to one of the reaction conditions to obtain curve Y. Question 5.2.1. What change was made to obtain curve Y? So, curve Y has more particles that have a higher kinetic energy. Therefore, the change made is that the temperature increased. Question 5.2.2. Give a reason for the answer to question 5.2.1. So, as we have said, curve Y has the maximum at a higher kinetic energy, therefore the peak shifted to the right. This means that the average kinetic energy of the particles increased. And that's all for this video. Thank you.